Welcome and congratulations. You have made it to the last unit of our course, Unit 8. We'll be skipping over Unit 7, at least in some of the classes, but this is Unit 8. Exponents, factoring, and quadratics, something that comes up a lot not only in your Algebra 2 and upper level classes, but also in standardized testing in several different ways. So let's jump right in and start a bit here with exponents with some of the basic rules. I'm going to be doing this very visually before I do the rule. You don't have to do it visually. You can, again, just like it's been all along, find what's most comfortable for you. Okay, multiplying exponents with like bases. In other words, the number or variable would be the same for each of your terms. X squared times x to the third. In all actuality means I am multiplying two x's, and then I'm multiplying that by 3 more x's with my x to the third. Each of these have an exponent of 1 on them if I don't see one. So if I add those up, 1, 2, 3, 4, looks like I have 5. Might be a pattern here. Let's see. X to the 6th, 3, 4, 5, 6, times x to the third gives me a grand total of 1, 2, 3, 4, 5, 6, 7, 8, 9. And you start to see the pattern. Oh, it looks like we're going to be adding the exponents up. But be careful. Now when you start bringing coefficients into the deal, the rules for the exponents on your variables, the like bases, are still the same. You can see I have 9 x's, so x to the 9th. But 3 times 4, I'm not going to add those. I'm going to multiply them, just like I normally would multiply a coefficient. So please be careful not to get that mixed up. And anything to the 0 power is always 1, and we'll talk about that a little bit later. So when you multiply terms, you add the exponents on like bases, but you're still going to multiply the coefficients. Okay? Add the exponents on your like bases, but multiply your coefficients together. Well, what happens if it changes a little bit? What happens if we go and have an exponent outside of our parentheses? Okay, for instance here, x to the 4th to the 3rd means I have 3 of those x to the 4ths. And we just learned from here that when we're multiplying those, we just add the exponents. 4 plus 4 plus 4 gets me to 12. But 4 times 3 equals 12. I wonder. So here, x to the 3rd to the 5th means I would have 5 x to the 3rds if I were to write this out. Run a little short on room here. We'll run over. It's okay. So if I wrote that out and then just added them up, 3, 6, 9, 12, 15, 3 times 5 is 15. Might have a pattern working here. This last one, again, can get a little tricky. Still going to add my exponents on my variables, gives me x to the 12th. But remember, like we said up in the first part, multiply the coefficients. 3 times 3 is 9, times 3 is 27. So definitely be cautious to make sure you don't get caught on that. What if we really screw some things around here and do this with a binomial term? Now, if you haven't done this before, this is called distributing within your binomial. Sometimes you might hear the word foiling. So, depending on how you do this, what we're going to do is we're going to look at the first term. So 2x times 2x is 4x squared, because again, I'd add the exponents. So there's my first. My outer, 2x times negative 5 is negative 10x. My inner is negative 5 times 2x, which is also negative 10x. And negative 5 times negative 5 is positive 25. Do you notice any like terms I could combine now in there? Those 10x's. So again, if I owe somebody $10 and I borrow 10 more, now I owe them 20. I'm not multiplying anymore. So notice I am not going to add my exponents here. We only add exponents when we're multiplying terms together, not when we're just adding or subtracting. Okay, and that gets me to my answer. I can't just distribute the 2 here like so many people do and say this is 4x squared plus 25. It gets me part, but it makes me lose the middle term. So the rule here is when you have a power to a power, you're going to multiply the exponents. Dividing exponents. Again, we're going to be visual at the start, but then we'll simplify it. X to the 4th means I'm multiplying 4x's. X squared means I'm multiplying 2. Cancel out until we run out somewhere, and the 2 I have left are up in the numerator and give me my answer. Now you might say right away, oh, well, this looks like it's not going to be bad because I'm just dividing. 4 divided by 2 is 2. Ah, but 4 divided by 2 is also 2. So we better take a look at another one just to make sure we get this right. Okay, 8 and 5. And again, once you know the rules, you don't have to do all the drawing, but I've seen over time that seeing a rule as you learn about it helps it to stick a little bit better than if you're just told a rule to work with it. So again, cancel until you run out of x's somewhere. My 3 x's are left up top. That's where I put my answer. Last one we're going to do visually because there's a little twist that's going to come in on this one that I want you to be aware of. So sorry if your hand's getting a little tired here from writing all these variables, but it's going to be well worth it. You're going to have a note sheet that actually means something to you later rather than just having written down a bunch of gobbledygook that doesn't mean anything. All right. So once we get all of our terms written down, just like we've been doing, we're going to go ahead, we're going to cancel things of the same variable, the same base, till we run out. We know that 4 divided by 2 is 2. 4 is bigger, my answer is going to go up top. I got 3 y's, they're up top. I got 4 x's, they stay down below. So here's how this rule works. Okay, you subtract exponents when you're doing this. But when you're doing these, you always do the big exponent minus the small, and your answer goes with the larger exponent. Let me explain what I mean. Some teachers say you always do numerator minus denominator, and I don't like that because it gets you into negative exponents. Here's what we mean using example C. Notice 7 is bigger than 3. 7 minus 3 is 4. The larger exponent's in the denominator. There's my 4. My answer's in the denominator. For my y's, 6 minus 3 is 3. 6 is larger, the larger value, so my answer goes up top. Just something to keep in mind to keep life a little bit simpler. And finally, when we move down to the bottom of our sheet, we'll talk a little about negatives. Now most of you are okay with this first part. But then you get to the negative exponents and you start thinking, oh, 2 to the negative first is negative 2. 2 to the negative second is negative 4, but it's not. Actually, what that causes is it causes you a fraction. It's 1 over 2 to the first power, 1 over 2 to the second power. And you'll notice as you go from the ends and work your way in, they're reciprocals. 8 and 1/8, 4 and 1/4, 2 and 1/2, and then 1 in the middle. So you have to watch for this. Negative exponents do not make negative numbers. Remember that. Negative exponents cause it to flip, okay? And like we were talking about before, things to the 0 power, whether they're numbers, whether they're variable terms, are 1, with one exception. Let's say this negative 7 to the 0 didn't have the parentheses around it. In that case, we do 7 to the 0, which is 1, but then the negative comes out front. So you have to watch out. That's one little detail that can get you otherwise. Okay? But let's say you do end up with a negative exponent sometime, even though we don't like dealing with them. Okay, we always flip those, and the mathematical term for that is taking the reciprocal of it, but only the part with the negative exponent. So anything that's not a fraction will make a fraction. Does the 4 have a negative exponent? No, just the x does. So the 4 gets to stay up in the numerator. The x, though, we're going to change its negative behavior by flipping it down to the denominator. Okay, only the parts with negative exponents. 5 and x squared, they're all good. They're all positive. Negative 10, now again, there's a negative, but it's not an exponent. So the negative 10 stays here. What about x to the negative third? That's not good. It flips up to the top, and then we have to simplify. 2 plus 3, because remember, multiplying, we add the exponents. Can I reduce 5 over negative 10? Sure. Negative 1/2. Okay, again, get my answer. And finally, here, there's a couple ways you can do it, but I have a feeling most of you are going to do this anyway. Most of you like to distribute when you see an exponent, and that's fine. 6 to the negative second, x to the negative sixth. And you're like, ooh, they're both negative. 6 squared, x squared. But there's nothing left on top. Oh, but there needs to be. You need to put that 1 there, otherwise it doesn't hold your place. And then we just do one last bit of simplifying and we're set. So again, we're coming down the home stretch. Keep working hard. You are almost done. Any questions, let me know.